All right, so here's an example of how to do one of these kind of problems. Okay, so this is the ball drop that we did in class. Okay, so here's my person. Okay, so I'm going to make my person consistent in all the pictures. All right. Initially, I'm going to have the ball be here. Okay, right? The only thing they're telling me here is that the total energy is 100 joules. Okay, so I'm going to have to scale that. I'm going to make the middle place maybe like when it was against the ground, right? And it sort of had its compression there. Okay, and then lastly, on the answer key, I made it all the way at the peak, but I think I'm going to make it like around here for this one, right? I think that might be a little bit more interesting. Okay, but again, it doesn't matter. Okay, all right, so here it would be moving back up now. All right, okay. So once I kind of get laid out what I want to do, okay, I know the total energy is 100, all right? So the most I'm going to need is 100. So I'm going to go ahead and, since there's 5 divisions here, I'm going to split this off into 20s, okay? And it doesn't always have to equal the total at the top. It kind of just depends, you know, what you've got, right? But in this case, that seems like nice and easy. Okay, 20, 40, 60, 80, and 100. Okay, and I guess I'll put the 0 there. Okay, all right, so I'm going to see what I've got now. Initially, EG, if I look at this picture of the ball, it's not moving. Okay, so it has no EK, and it's not stretched or compressed, so it has no EE. So the only thing it's going to have is EG because it's all the way at the top. All right, and since I know the total energy has to be 100 joules, it has to all be EG at this point because there's nothing else it can be, right? And remember, no thermal in the first picture ever, okay? All right, so that's going to be what I have to work with is 100, okay? Now, when I'm in the middle position, all right, I know I'm going to have some kind of EE because it's compressed, all right? It's not moving, and it's on the ground, so it's not going to have any EK or EG because it's on the ground, so no EG. It's not moving, so no EK, all right? But it's going to have some EE, all right? Now, you may or may not know this, right? But if you remember when we did the ball drop, right, it doesn't go as high as it did upon the drop, right? So like when I drop it from this level, it's only going to go back maybe to like this level, right? It's not going to go all the way back up. So that means some energy is being wasted, okay? So I'm going to go ahead and just give 1 bar of thermal, okay? There's going to be ETH in the smack here, right? In that hitting against the ground. There's going to be some energy, those particles in the ball and the floor, when they collide, they're going to get a little bit hotter, okay? So that's going to lose some of that energy or waste some of that energy, okay? So if, say, that's 20 joules of thermal, and I know I have 100 total, and this ball is very compressed, right? So then I'll be able to know that that's going to have to be 80 joules plus 20 joules is 100 joules, because the total has to stay the same, okay? I know, again, on the ground, so no EG, not moving, so no EK, very compressed, so lots of EE, and some thermal wasted in that collision, all right? Okay, now, this is what's different than the answer key, because I went ahead and did to the peak in the answer key, all right? But I'm going to do this one a little bit differently, okay? Now, is it above the ground? Yes. Is it moving? Yes. Is it stretched or compressed? No, not anymore. And is there thermal? Well, there has to be thermal because there already was. Remember, it can't go back, okay? Now, there's not going to be any additional thermal generated, right? Because there's no more smacking on the ground or anything, okay? We're going to ignore the air because that's just complicated, all right? So there's not really going to be any more thermal, but I have to at least keep the 20 that I had before because that cannot go down, all right? So now I have some split between the EG and the EK, and I don't know, it looks like a little less than halfway up, so I'm going to go ahead and give this 40, okay? And then I'm going to give this also 40. All right, because then I'm going to have 40 plus 20, that's still going to be 100. Okay, right? So that's how you're going to work these, okay? You have to just make the numbers work based on what you know. So I still am doing everything I knew before, okay, which is that the ball is high above the ground, so it has a lot of EG. It's not moving, so no EK. It's not compressed, so no EE. In the middle picture, on the ground, right? So no EG, on not moving while it's turning around, so no EK, a lot compressed, so a lot of EE, and some thermal in that smack, all right? And then on the way back up, some EG, it's lower than it was before, so not as much as the first picture. It's now moving, okay? And it's not compressed anymore, and you have to keep that thermal, okay? Can't decrease. This cannot decrease, okay? All right, so this is what I want you to try to do for these 6 scenarios before next class. You need to make sure that you finish these because we're gonna go over them, okay? And then the quick quiz is gonna be about the energy skate park stuff that we did, not this yet, okay? That'll be the next one, all right?